Hello everyone, this is SAVITHA Acharya from Canara Engineering College. In this video lecture, we look into a few exercise problems of Module 2. We'll begin with the first problem. Practice writing the following numbers. In that first one is decimal number 123 as a sized 8-bit number in binary. Use underscore for readability. So I'll just write the number in binary, say powers of 2, 2 power 7, 2 power 6, 5, 4, 3, 2, 1 and 0. So 2 power 7 is 128, so I cannot use this, this will be a 0. This is 64 plus 32 is 96, plus 16 is 112, plus 8 is 120. Then I need another 3, so this is 4, so 3 is 1, 1, okay. This will be the binary equivalent. So writing this in binary, 8 tick B 0 1 1 1 underscore 1 0 1 1. Note here we are using underscore just to improve readability. It's not going to add any meaning to it. Second one is a 16-bit hexadecimal unknown number with all x. So 16-bit number should begin with 16 as the number of bits. Tick H for hexadecimal, and since all bits are unknown, you can do with one x. It indicates that it's a 16-bit number with the all x. Next one is a 4-bit negative 2 in decimal. And in addition, write the 2's complement form for this number. So remember, negative numbers always should be written with a negative sign at the beginning, not after the base. Okay. So it is 4-bit number. So 4 tick decimal. You have to write the number in decimal. So decimal and represent it in decimal. So 2 in decimal. This is the correct representation of a -2, negative 2 in decimal. You cannot put the negative sign after this D. That becomes invalid. Now to write the 2's complement of this number, first I will write the representation of 2 in binary. This is +2. This is +2. To find -2, I need to find the 2's complement of this number. So first I will find 1's complement, 1, 1, 0, 1 plus 1 will give me the 2's complement. So 1 plus 1 is 0, 0 plus 1 is 1, 1, 1. So this is the 2's complement of of 2. So it will be written as 4 tick B, 2's complement is in binary 1, 1, 1, 0. Okay. Next one is an unsized hex number 1, 2, 3, 4. So unsized means by default it is 32-bit. 32, it is asked to represent in hexadecimal. So H 1, 2, 3, 4. Okay. Second question is, are the following legal strings? If not, write the correct strings. In that A, this is a string displaying the percentage sign. So before going for the answer of this, we look into what are escape characters. So I'll just list the escape characters. Escape characters in Verilog and the corresponding character displayed. Okay. So a \n will display a new line. It will go to a new line. \t, a tab will be inserted. The character displayed is tab. Percentage, two percentage symbols. Okay, 2 percentage symbols. The character displayed is a percentage symbol. Double backslash, the character displayed is a backslash. Backslash asterisk, the character displayed is asterisk. and backslash OOO, some valid octal number. That value will be, octal number will be displayed. Okay. So here for this A, question number A, the correct answer is, correct string should have been, this is a string displaying the double percentage. I want to display the percentage sign, so it's a escape character, so double percentage sign. B, out equal to in1 plus in2. So this is enclosed in double quotes. There is nothing wrong in it. It's a valid string. So this answer is right. Next one, please ring a bell backslash 007. So this is a octal number. So this is going to display 7. So in octal, so this representation is right. Next is, this is a backslash, single backslash. This is a backslash, a single backslash character, backslash n. So here to display backslash character, you have to use double backslash. So the correct answer would be, this is a backslash, double backslash character. Okay. Question number 3. Are these legal identifiers? So you know the identifier rules. Okay, the identifier can be containing any alphanumeric values. Okay, and it cannot contain any special characters unless a underscore, and the identifier cannot begin with a letter. Okay, so the first A is system1. So this is a valid character, valid identifier. So this one is right. Okay. Next, 1 reg. So this is identifier begins with a number. So that's why it's a invalid value. So this is wrong. Next one is $latch. Again, this is containing a special character. I've told in the beginning itself, the identifier name cannot contain a special character except for underscore. Next one, $exec. Again, same thing. It cannot contain a special character. So this representation is also wrong. Question number 4, declare the following variables in Verilog. So in the previous question we have seen what are legal identifiers. So right here you have to declare the variables in Verilog using those rules. Okay. The first one is an 8-bit vector net. Okay. An 8-bit vector net called a_in. So you are required to declare a net named as a_in. And this should be a 8-bit vector, not a single value. So how do you declare net here? Net is declared using the keyword wire. Okay. And the name of the this thing is a_in. So this will declare a wire a_in will declare a_in as a single bit vector, a single bit net. But now I want it to be a 8-bit vector. So to declare a 8-bit vector, I will use the size 7 down to 0. So wire 7 down to 0, a_in is the answer. Next one, a 32-bit storage register called address. Okay, bit 31 must be the most significant bit. Set the value of the register to a 32-bit decimal number equal to 3. So we'll see first the first part only. So you are required to declare a 32-bit register type signal named as address. So how do you declare register? For declaring register, we use the keyword reg, and the name of the register is address, address. Okay. Now this should be a 32-bit register. So again an additional condition is given, that is bit number 31 must be the most significant bit. So here you can actually declare the register vector as 0 down to 7 or 0 down to 31 or 31 down to 0. But since it is specified here that bit number 31 should be the most significant bit, so you don't have any other option. It should be declared as 31 down to 0 address. Okay. In the previous question, that is this one, there is no conditions mentioned here, so you can declare a underscore in as 7 down to 0, or you could have also declared it as like this, say wire 0 down to 0 up to 7 a underscore in. In this case 0 becomes the most significant bit. Here 7 is the most significant bit. So whatever you write to the left of this colon will be the most significant bit position. Okay. So here it is mentioned bit number 31 should be the most significant bit. So you have to declare it as 31 down to 0. Further, set the value of the register to a 32-bit decimal number equal to 3. So once I have declared, I want to assign address equal to value equal to 3. So since the address is 32-bit number, so 32 pick D. So it is asked to assign a decimal value of 3. So 32 tick D 3. This is the answer. Next one, an integer called cout. So I need to declare an integer called cout. So that is integer is the keyword to declare integer, and name of the identifier is cout. Okay. Next, a time variable called snapshot. So to declare a time variable, time is the keyword and name of the identifier is snapshot. Next, an array called delays. Okay, array contains 20 elements of the type integer. So you need to declare an array of type integer. So integer, the array name is delays. Now it should contain 20 elements. So 0 up to 19. Okay. Next one, a memory MEM containing 256 words of 64 bits each. So a memory would be declared as a register. Name of the identifier is MEM. It's an array of 256 words. So my size would be 0 to 255. And each location consists of a 64-bit data. So that should be a 64-bit vector. So that I will declare as 63 down to 0. So register 63 down to 0 MEM of 0 to 255. So this declares a register named as memory with the 256 memory locations, and each location capable of holding 64-bit data. Last one is a parameter cache size equal to 512. Parameter is declared using the keyword parameter. The name of the parameter is cache underscore size, and it should be assigned the value 512. This is the representation. Question number 5. What would be the output or effect of the following statements? In that A, latch equal to 4 tick D12, dollar display, is a system task. The current value of latch equal to %b/n latch. So here the display task, in the display task it is required to display the binary value, equivalent value of latch, whereas the latch value is given in decimal. So the output of this piece of code will be the current value of latch equal to %b. So you should be writing the binary equivalent of 12 1100. Next, b equal in underscore register equal to 3 tick d 2 $monitor inside the braces $time. So this is again a system task. In register value equal to %b/n in register 2 down to 0. So here we have just declared in underscore register as a 3-bit vector, and its value we have mentioned in decimal, that is 2. But while displaying, monitor is same as display. Only difference between the display task and the monitor system task is this monitor system task will be displaying the value of the required register or signal every time an event occurs on that signal. That means every time that signal changes, the monitor task will be displaying that value. So here monitor task, what we do is $time. So we want to display the system time here, and the string to be displayed is in register value equal to %b. So this in register value, it is represented as a vector 2 down to 0. So the 3-bit vector you should be inserting here. So the output of this program will be, so $time initially it will be, the system time will be 0. Okay. In register value equal to, now this in register should be represented in binary, that is 3-bit binary, that is 2, that is 3 tick b 0 1 0. Okay. Next one, tick define mem underscore size equal to mem underscore size 1024. Following that, $display, the maximum memory size is %h tick mem size. So we have used the system task compiler directive define to define a constant mem underscore size, and the value we have assigned to that is 1024. Now I am using a display system task to display the maximum memory size is, now the memory size I want to display in hex, that's why I have written %h, and this is how you refer to the compiler directive, that is tick mem size. So the output of this program is the maximum memory size is %h. Now you have to convert 1024, this one 1024 is given in decimal, this is in decimal. Okay. Now since it is asked to represent in hex, the decimal hex equivalent of 1024 is H400. Okay, this is the output. Question number 6. What are the basic components of a module? Which components are mandatory? So as we have already seen, the module structure comprises of the module keyword followed by the module name, then the port list in the first line. Immediately following that is the port declarations, whether they are input or output. Then we have parameters if any, then declaration of wires, registers and other variables. After that, in the main body of the program, there can be data flow statements or instantiation of lower level modules, that means gate level statements, or always and initial blocks and tasks and functions. These comprise the behavioral statements, and finally terminated by the end module statement. So these are the basic components of a module. It is not necessary that all these components should be present in all modules. Okay, there could be a mix and match. Now, which components are mandatory? Only module keyword, module name and the end module are the only things that are mandatory. You need not even have the port list in the first line. Okay, once you don't have port list, then there won't be port declarations as well. So only module name, module keyword, module name and the end module statements are mandatory. Question number 7. Does a module that does not interact with its environment have any I/O ports? Does it have a port list in the module definition? So, if a module that does not interact with its environment, the question is, if a module is there which does not interact with its environment, does it have any I/O ports? The answer is yes. It can have I/O ports even though it is not going to interact with its environment. Then does it have a port list in the module definition? The answer is no. If it is not going to interact with the external environment, then it need not be mentioned in the module definition line. Question number 8. A 4-bit parallel shift register has I/O pins as shown in the figure below. So this figure is a 4-bit shift register. It has got two inputs. One is register underscore in, which is a 4-bit vector. The other one is clock, and one output which is again a 4-bit vector, that is register underscore out. Okay. Write the module definition for this module shift register. Include the list of ports and port declarations. You do not need to show the internals. So internal details is not required. We just need to define this port. So how do we start with? So this starts with the keyword module. The name of the module is shift underscore register. So always make it a point to write the actual module name inside the block diagram so that there won't be any confusions. And also the port list, the terminals also should be named exactly what you're going to name them in the program. So the port list is, say, I will start with the output first. So register underscore out, then register underscore in is the input, then the next one is clock. Okay, clock, close, semicolon. Now port declarations, the first one is the output register, output register out is the output port, and it is a 4-bit vector, 3 down to 0. Next input is again a 4-bit register, that is register in. One more input is there, that is clock. Okay. So there is some module of the program which is not required. The module is end using the end module. Question number 9. Declare a top level module stimulus. Define register in 4-bit and clock 1-bit as register variables and register out 4-bit as wire. Instantiate the module shift register and call it SR1. connect the ports by ordered list. Okay, so here you have to declare a top level module, that is the stimulus module with the name stimulus, and instantiate the module that we have just declared in the previous question. Okay, so the module definition will start with the keyword module. The name of the top level module is stimulus. Okay, this will not have any port list, so just a semicolon. It is asked to declare register in and clock as register type variables. So declare register register in, okay, as a 4-bit register type variable, and clock as a single bit CLK as a single bit register, and register out as a 4-bit wire. So wire 4-bit, that is 3 down to 0, register in. So note down here, all the variable signals are mentioned as in capital letters. That's what it is specified in the question. Instantiate the module shift register. So instantiate shift register. So the instantiation line will comprise of the name of the module followed by the instance name. So instance name should be given as SR1, that is what is mentioned here, and connect the ports in order. So in the module definition of shift register, we have declared first the 4-bit output register, output port register out, followed by 4-bit input port, that is register in, and lastly the clock, that is a single bit port, input port. So here the output port should be, sorry, this is register out. So the output port is register out and the input port is register in, followed by CLK, that is the single bit input port. Okay, so they will be connected by ordered list. So as I've told you in the module definition, first is the 4-bit output port, next is the 4-bit input port, next is the 1-bit input port. Okay, then end module. Question number 10. Connect the ports in question number 9 by name. So in question number 9, we have instantiated the shift register module and given it name as SR1. So here the same thing we have to instantiate, but now we have to instantiate by the ports, we have to connect by name. In the question number 9, we have connected by ordered list. So the answer here, I just write the instantiation line here. Shift register is the name of the module. Okay, then let the instance name be SR1. Now inside the braces, now the actual module, in the actual module definition, the actual port is, output port is register out, that is to be connected to the register out. This is in capital, this is in the top module, that is the stimulus module. We have declared the corresponding signal as register out in capital letters. Okay, followed by, so now here since it is connect by name, the order is not important. So what I can do is I will write next clock. So CLOCK, this is the signal name that we have given in the module definition line, dot clock, and in the stimulus module we have named it as CLK. Okay, then the last one is register in. So register in we have declared as small letter register in the module definition line, and which is to be connected to capital letter register in the stimulus block. Okay. Question number 11. Write the hierarchical names for the variables register underscore in, clock and register underscore out. Note here, these are the signal names that we have declared in the top level module stimulus. Okay. In the stimulus module, we have declared these as these signals, that is in capital letters. So the hierarchical names for these registers or these signals is stimulus and dot register underscore in and stimulus under dot clk clock and stimulus dot register underscore out. Okay. So since these are the signals in the stimulus module, the hierarchical names is first you have to mention the name of the module followed by a period and the register name or the signal name. Okay. Question number 12. Write the hierarchical name for the instance SR1. Write the hierarchical names for its ports, clock and register in. So here now the question is to write the hierarchical name for the instance SR1. Instance SR1 means this is an instance which is instantiated inside the stimulus module, that is the top level module. Okay. So the SR is a component of stimulus. So to refer to SR1, the hierarchical name is the name of the module from which it is referred is stimulus period SR1. Okay. The hierarchical name for clock and register in. These clock and register in, if you see this clock and register in, these are the signals, these are the ports that you have declared inside the shift register module. These are in lower case, these are declared inside the shift register module. So to refer to these signals from the stimulus block, the hierarchical name is stimulus dot SR1 dot clock. That means the top level module is stimulus and the module containing this signal is SR1 and the name of the signal. Similarly, stimulus S dot SR1 dot register underscore in is the hierarchical name for referring the register underscore in port. Thank you.